Okay, a new limit, and we have a new theorem to attack it with. So already we've seen that when x goes to 0, sine x over x goes to 1. Now we have a new one, which is that when x goes to 0, cosine x minus 1 over x goes not to 1 but to 0. I've never had any real luck memorizing this one, but I've trained myself to recognize situations where it might come up, where you have a cosine and something else over x, and generally that's enough. If you at least see that this thing might be relevant, you can look it up or Google it if you need to remind yourself what the exact structure is. So if we're going to try to apply that here are things that you must have. You must have a 1. This can't be cosine x minus 7 or anything like that. So whatever is here must be exactly 1. And these must match. The argument of your cosine function and your denominator must be exactly identical. So if you can make that happen, this limit formula can help you. Can we do that here? We absolutely must have a 1 here, so factoring a 2 out seems like a reasonable place to start. Let's do that, and then we'll see what else we need. Out comes the 2, and that leaves us with cosine x minus 1 over... It's 5x. I'm pulling the 5 out because these must be identical. If this is cosine of just x, then this denominator better be just x, which means the 5 is inconvenient and we want to get it out of the way. Now, you could leave that written like that. If you want to really split it off, you could say limit as x goes to 0, 2/5 times cosine x minus 1 over x. That looks nice. I'd be happy with either one of these, frankly. And this is exactly what we have in our limit theorem. Cosine something minus 1 over something as something goes to 0. All of this evaluates to 0. Now, the bad news is that that makes this kind of a boring limit. We get 2/5 times, and this whole chunk goes to 0, and 2/5 times 0 equals, 0. So not a very rewarding answer, but that's what you have to do. So when you see this thing happening, generally force this 1 any way that you have to by doing factoring or what have you, and then see if you can get the argument of the cosine and the denominator to match. If you can, then this is going to work. If you can't, then you thought you had an evaluatable limit, and it turns out you don't. It's time to either try different tactics or say this limit doesn't exist.